Okay, so today we are going to take the last two sections that we've learned and we're going to put them together. So just like our equations, we can solve inequalities in multiple steps. So that's what we're going to start with. So for this one, we have 9 plus 4t is greater than 21. Our first step is going to be to get this 9 away from this t. So we are going to subtract 9 from both sides. That leaves us with 4t is greater than 12. Okay, our next step is to get this 4 away from t. So we are going to divide both sides by 4. That leaves us with t is greater than 3. Okay, so that's going to be our answer. When it says check the solutions, that means that we're going to see if any of our solutions work. So we're going to pick a number that's bigger than 3 to put back into this inequality. So a number that's bigger than 3, I always just go with the next number, which would be 4. So if we had 9 plus 4 times 4 is greater than 21, that gives us 9 plus 16 is greater than 21, and 9 plus 16 is going to be 25. Greater than 21, so we know that we got it right because 25 is greater than 21. If we were to put this on a number line, we would have 3, we'd have an open circle, and it would be shaded to the right, which means our function notation would be 3, infinity with parentheses on both sides, okay? So go ahead and start trying the got it problems. You would have plus 7, that gives us negative 6a is less than or equal to 24. We are going to divide both sides by that negative 6. Remember, when we multiply or divide by a negative number, we have to flip that sign automatically. Okay, so that leaves us with a is greater than or equal to negative 4. So if we put this on a number line, we have negative 4. We would have a closed circle at negative 4, and we would shade to the right, which means our function notation would be open bracket, negative 4, infinity, close parentheses. Over here, we're going to subtract 5 from both sides. That leaves us with negative 9 is less than negative 3n. When we divide by that negative 3, we need to switch the sign or flip the sign. That leaves us with 3 is greater than n. If we switch that around, that should be n is less than 3. And putting it on a number line, we have 3. We have an open circle at 3, and we are shading to the left, which means our function notation would be open parentheses, negative infinity, 3, close parentheses. Okay. Our next one doesn't look like it gave you very much room. So we have subtract 30 from both sides. That leaves us with 20 is greater than 0.8x. If we divide both sides by 0.8, that gives us 62.5 is greater than x, and if we switch that around, that gives us x is less than 62.5. On a number line, we would have an open circle at 62.5 and shade it to the left, and our function notation would be that negative open parentheses negative infinity, 62.5, close parentheses. On to the next one, we are going to use distributive property. So we're still solving the equation, we're just using distributive property. So we should distribute this 3 into that parentheses. That gives us 3t plus 3 minus 4t is greater than or equal to negative 5. When we have 3t minus 4t, that gives us negative t plus 3 is greater than or equal to negative 5. We are going to subtract this 3 from both sides, and that's going to give us negative t is greater than or equal to negative 8. When we have this negative t here, we are going to divide by negative 1 on both sides, which means we have to flip that sign. That gives us t is less than or equal to 8. On a number line, we would have a closed circle at 8, and we are shading to the left. And our function notation should be open parentheses, negative infinity, comma, 8, closed bracket. Okay. Try the next one by yourself. We're going to distribute that 2 through, so we should have 15 is less than or equal to 5 minus 8m minus 14. If we have 5 minus 14, that is going to give us negative 9, so we should have 15 is less than or equal to negative 8m minus 9. We're going to add 9 to both sides. That gives us 24 is less than or equal to negative 8m. And we are going to divide by that negative 8. When we divide by negative 8, we flip the sign, which leaves us with negative 3 is greater than or equal to m. But we always want that variable first, so we should have m is less than or equal to negative 3. On a number line, we should have a closed circle at negative 3, and we are shading to the left, which means our function notation should be open parentheses, negative infinity, comma, negative 3, closed bracket. Okay. So if we have a variable on both sides, we're using the exact same way that we've always done it. We need to get our variables on one side and our constants on the other, okay? So the first thing I'm going to do is I'm going to move this 3n over to the other side. So to do that, I'm going to subtract 3n from both sides. That leaves me with 3n minus 1 is greater than 8. Now what I'm going to do is I'm going to get this constant onto the other side, so I'm going to add 1 to both sides. That leaves me with 3n is greater than 9. The last thing we need to do is we need to get this n by itself. So we are going to divide by 3, which leaves us with n is greater than 3. On a number line, that would give us an open circle at 3, and we are shading to the right. And our function notation would be open parentheses 3, comma, infinity, close parentheses. So go ahead and try this one on your own. What I'm going to do is I'm going to add 2b to both sides. That leaves me with 5b plus 12 is greater than 27. Okay. So when I do that, what I want to do is subtract this 12 from both sides, which leaves me with 5b is greater than 15. And my last step is to get this 5 away from b, so I'm going to divide both sides by 5. That leaves me with b is greater than 3. So on a number line, we should have an open circle at 3, and we are shading to the right. And our function notation should be open parentheses 3, comma, infinity, close parentheses. Okay. So sometimes when we're solving an inequality, the variables cancel out. So when that happens, there's two different possibilities. So if the inequality statement is always true, so if we have 4 is greater than 1, that's always true. That means that our solutions are infinitely many. Okay, and if the inequality statement is never true, so if we have 9 is less than or equal to negative 5, then that means that the inequality has no solution at all. Okay, so let's start going through these. The first thing we need to do on this one is we need to distribute that 2 through, so we should have 10 minus 8a is greater than or equal to 10 minus 8a. Okay, so if I add this a to both, or this 8a to both sides, those cancel out, and that gives me 10 is greater than or equal to 10. 10 is equal to 10, so this statement is true. So since the statement is true, we have infinitely many solutions. Okay. So on this one, we need to combine like terms first. So we should have 6m minus 5 is greater than, we have 7m minus m, that leaves us with 6m plus 7. We subtract 6m from both sides. Those cancel out, and that leaves us with negative 5 is greater than 7, which is not true, and that means we have no solution at all. Okay, so go ahead and try the got it problems. We subtract this 5n from both sides, cancel out, that leaves us with 9 is less than or equal to negative 1, which is not true, so that we have no solution. Okay, and over here we should have 8 plus 6x is greater than or equal to 6x plus 2. So subtract 6x from both sides, cancels out, and that leaves us with 8 is greater than or equal to 2. That is true, so we have infinitely many solutions. Okay, and that should be it for the day.